All right, that looks better. Okay. All right, well, I'm still getting some funny lines on my side, but it looks like it's okay when I play the recording back. So hopefully everything works out okay. Okay, so how are people doing on homework? Okay, I see mostly nods are okay. It turns out that there's some change in office hours for this week, so Kenneth is not going to be available today. It's going to be tomorrow, and David wasn't available yesterday, and turns out he has a sick child and won't be available today either. So how are people doing? Is that going to be a constraint for, there's a homework that's due today. It was on documentation. I think that's a relatively easy one, so I'm guessing that that's not a big deal. Is anybody have any problems that, you know, because the other thing we could do, we could try and either change that homework due date or something else. I mean, the problem is you have 2 homeworks a week, and so we shift one. It's not like you necessarily, you breathe that much easier. So, and I also think the documentation one is relatively easy, right? Okay, we're good there. All right. Anything else? Questions, concerns at this point in the class? I'm going to talk a little bit about the class project in a second because we haven't really talked about that yet. All right, good. Let's see, how many people have been using the videos? Okay, good. All right. I assume that part of the reason why class attendance has dropped is that the videos have been too effective. So, all right. Well, good. I'm glad to see that the videos are useful. Okay. So let's talk a little bit about the class project. The class project is going to be on ecosystem modeling. How many people here have done some ecosystem modeling already? Okay, doesn't go very deep. It provides you, it's a self-contained project that provides you with the background. And the basic idea is that the species in an ecosystem have an economic value. And then you've got the ecosystem model itself, that how one species contributes to other species. And that's what the model is about, is determining economic value. So that's sort of the premise in terms of the application. What you'll see in terms of, what you'll pull together in this is a lot of these concepts about design, which, we'll get to in a couple of lectures, and then some basics of programming and programming structure. My feeling is it's not, the programming part is not terribly challenging, and so I think that it will be well within your capabilities to do it, and also the design parts too. And again, we're available for comments and feedback. Let me tell you a little bit about the project here. So this is for students. How many students here are taking the class for 3 or 4 credits? Okay, a good number. Okay, so the project's required for anybody taking the class for 3 or 4 credits. We're planning to do this in teams, and so we have to figure out how to do teams. What I'm going to do is I will send you a survey form and ask you if you have some preferences for who your teammates are. We'll do our best to honor that, and what we're trying to do is sort of mix people in the right way in terms of sort of balance about what people have shown the way of strength on the homework so far, so we sort of get a balance type of thing, but also taking into account your preferences. And so that's the survey that you'll be getting shortly. And then on the course web page, on the left-hand side, on the navigation bar, there's something that says other links, and down there's something there that says class project. And if you follow that link, you'll get full details. It's a Google Doc. It's about 2.5 pages and describes it, and there's a reference to an article that this is based on. Okay, all right, so today we're going to talk about object-oriented programming. How many people have heard the phrase object-oriented programming before you came into this class? Okay, so a few people. And how many people have done something with object-oriented programming? Okay, not really. Okay. All right, well, that's great. I'm a big fan. It's actually a technique that's been around for a very long time, well over 20 years. But I think it's something where, like many ideas in computer science, it takes a different way of thinking about problems, programming problems. But once you go there, there's tremendous value in doing it. So what we're going to talk about today is, sort of some basics, some philosophy about objects. We're going to, and then this is more philosophy. Why objects? The object basics is going to really be about the constructs in Python that support object-oriented programming. And one of the things we're going to do, we're going to apply this to, is reading comma-separated variable files. We haven't really talked about input and output in Python, or for that matter, MATLAB. There are a lot of areas we won't necessarily, this is not really a programming class, it's more of an engineering class. And so the expectation is that we give you enough skills and knowledge so you can go out and learn the bits and pieces that you need to do a full project. And in fact, I mean, realistically in software, you will always be doing that. There will always be new technologies and new ways to do things. So those are essential skills. So that will be our application today. And then we'll sort of pull that together, and I'll talk about the homework as well. Okay, so object-oriented programming really started from one of the core challenges in software systems, and that is that unlike anybody who deals with physical systems, like biologists or chemists or physicists, you know, you spend a lot of time dealing with the mechanics of what you have to pull together, running experiments in laboratories and stuff like that. In computer science, it's like all in your head. And so you can spend a lot of time thinking about things that are really complicated. And so as a result, it tends to be that a lot of computer problems just are conceptually very, very complicated. I mean, I give you this example here as a physical example. It's an assembly for a vehicle. But I mean, I think it gets to the point. I mean, here's something that you're trying to put together. You've got the parts list, which is sort of mapped in here by, and anybody who's assembled a kit has seen this kind of thing. You've got the parts list, and then you've got something about how the parts fit together. And that's the kind of thing that you want to do in a software design, and certainly when you're building software. And objects give you a way of going about this. And basically, you've got the part, you've got what it is it's supposed to do, and then how its interactions with other pieces. So in general, you have these complicated systems, and the question is, well, how do you manage them? How many have heard the phrase abstraction hierarchy? Is that something you've run into? That's a core concept in computer science. And the idea is that there's a lot of time that's spent about how does one concept relate to another. So, I'm a person, but I'm also male. That's, how do these concepts relate to one another, the attributes and contributions of them. So this is one thing that you can do. You can create hierarchies. Another kind of hierarchy is a geographic hierarchy. You may have, your zip code, your state, your country, that type of thing. These things are often useful in terms of combining together data, for example, aggregating and disaggregating data. So, for example, an example of an abstraction hierarchy is like a locomotion system. And you can have various different kinds of locomotion systems. They could be cars, they could be trucks. But if you look at one at this high level that you're looking at, like autonomous, four-wheeled or wheeled systems, well, not autonomous, but they're wheeled systems with an engine. You'd have an engine, you'd have some sort of energy transfer, and you have the wheel assemblies. And the idea is that each element in the hierarchy has, and this is sort of the core notion of something that's object-oriented, you're looking at two things, really. That each element, each object has properties. It may be like height, weight, color, whatever. And it has certain things it can do. And it's those combination of characteristics that describe each part in the system and allows you to assemble them in a way, connect them in a way, so that they do something you want to have done. And we'll go into this more detail in the next lecture, which is going to be on design. But for this lecture, I want to more introduce you to this thought about when you talk about an object, you're talking about what it's called its attributes is the term we're going to use. Properties is used synonymously, but I'm going to use the word attribute because that's more common in Python. And then what actions it can perform, and in Python the term is method. And those are the ways you describe a component. And today it's going to be mostly about the mechanics about how you do that in Python. So let's give some examples here. Here we have a car hierarchy. These are all cars. This is sort of like the generic car, the class car, and then you can have them with different characteristics. And those characteristics are about, their attributes are color, it may be size, it may be weight. All right, so that's where we're going to describe things. So let's start out with this notion of you know, sort of like how we're going to bundle things together. So we're going to talk about, we're going to describe objects in terms of this bundles of properties and actions that they can do, and that by doing this in the right way, we're going to get some reuse, because the thought is that if there's a lot of common characteristics of what a generic car is, then if that's common, we don't have to repeat that same description for each type of car over here. And that's the way reuse works. So, that makes sense so far? I mean, the other thing that's a little bit different about this, which we saw a bit in the Python basics, is that we've bundled together data, which are really the attributes, with code, which are the actions or methods. And that's another characteristic of an object-oriented system, is you bundle those together, and so that you don't talk about just typically a function that's applied to an object. You more look at what functions can be applied to that object. So like a list. You can append to a list. You can sort a list. Right? That doesn't make sense for an integer. Right? So that's sort of the thought as well. And one of the consequences of this is that generally when you talk about object-oriented systems, instead of talking about verb-noun, like, you know, length of something, you talk about something its length, or something its, you know, append, or something like that. You start out with the noun, the data, the object, and then talk about the things you're going to do to it. And that's another thing that's, you know, at least syntactically a little bit different about object-oriented systems. All right. Okay, so that's sort of the philosophical basics. Let's get into more specifics, go through this notion of objects. So let's continue with this idea of the car and car hierarchy. So I'll make a distinction here. I've been talking about objects and using the term sort of loosely. There are actually two related concepts that are somewhat easy to confuse, but very important to distinguish. There's the notion of a class. A class is really a template. It's not something that you generally manipulate directly. And then there's an object. An object is an instance of a class, something that got stamped out by that template. The template class will contain the attributes and the methods, the actions you can do. So it will say, for example, that a car has color, a car has weight, a car has a length. It won't specify a value. It'll just say, you've got to fill in these blanks. That's part of your template. That's part of your boilerplate. The object, when you create the object, that's when you fill in the blanks. And then all objects that are of the same class have the same methods. Okay? That's sort of a core idea here, this distinction between class and object, class being the template. So that's what we're getting at here. So we'll go through this a step at a time, and then we'll do a little bit of interaction programming-wise, because I think that will help as well. All right, so class versus object. So we're going to have this class called car. And cars have, and we're just talking about the attributes right now. We're not talking about the things it does. So it has a color, it has a type, and it has a speed. So you know, here's my car. I'm going to create an object that's going to be my car, Joe's car. And Joe's car is going to be blue, it's going to be a sedan, and it can't go more than 100 miles an hour. Right? But then I can create other cars too. I mean, see, Dave unfortunately isn't here, but so Dave's going to have this sporty red car, and it's going to go 150 miles an hour. So what we're doing here is we've got the same attributes for all members of the class, but they have different values assigned. Okay, that certainly makes sense. And then there's a form about how you make the class declaration. So now we're getting a little bit more into the mechanics of a class and what you do in Python. And again, I'll get to some actual code in just a second. So when you declare a class, you say, and this is going to be your template, you say class and then you give a name, like class car. So these things in angle brackets here are meant to be something you have to fill in the blanks. So that could be car. The other thing that becomes important, the last time we talked about functions in Python. So when you define a class can have methods. These are the actions you can perform. And there's one very important method. It's optional, but it's very important. It's the one that allows you essentially to create the class, what's called the constructor construction of the class, and that's this method, and it's sort of a funny form of it. It has two underscores, and then the lowercase init, and then two other underscores. That's a special function or method in the class, and that's the one that describes, that gives you, when you create the class, the ability to sort of customize it. That's when, when I create Joe's car, I will specify it's a sedan, it's blue, it can't go more than 100 miles an hour, and Dave's car would be different. And then the other thing to keep in mind is that a class is, so what we're going to do, we have this template. When we create a class, when we create an object in that class, we have what's called an instance of the class, or an object. Those are used equivalently. Many times you want to refer to data which is just within that object. So I've got color, for example. Color is a class variable, or a variable that's used for all members of the class. But what I would like to do is refer to the value of the one that's my class. And the way you do that is the preface self, or self dot. Now, we'll go through this. I'm dumping a whole bunch of stuff on you right now, and we'll go through detailed examples of this. That's what this session about, this lecture is about. So here's the example about how you declare the class. So I'm class car, and I've got this this init method, or that is used to construct an element of the class. And you can see the arguments I've got here. I have to say that it's for this particular object, I have to use self. That's one of the arguments. And then I've got the other things that I want to use to customize the class, these attributes over here, or these attributes over here. So I've got color, type, and speed. The other thing that we have here is that I want to assign this value so that I know it for the instance that I create. And that's how this constructor or underscore init method works, is you say self.color. So that's now a variable that's used within this particular object, the one I'm creating, and I assign it the value of what gets passed. Yes? Okay, I can't hear you. I heard you type it into Python and you put in purple?
Type the word type in purple.
Yes. Okay, so if you put in type here and you said type equal, and in here you had in quotes a string purple?
No, just typing it in as it is. Everything else, most words are fine except so self-color.
Oh, okay, so okay, so I'm defining the class. And instead of type over here, I put in the word purple.
No, the word is type, but then the color of the word is purple. And everything else, self-color and speed are black.
Okay, I'm not following what you're changing. Yeah.
I think she means that type is a keyword.
Oh. Did I do that? Okay, my apologies. Yes, I think you're right. That may be a problem. Let's try this out. Actually, let's switch to code right now. I think, because I run all this code. I think it works. It may cause problems if you use type in other cases, but let me see if this actually works. That's a good question. So the concern is type a keyword in Python? Okay. Yeah, actually it is. It shows up as a keyword over here. So amazingly, it seems, oh, that's interesting. Okay, well, let's try this. I think it actually works, but your point is well taken. So the point is that in most programming languages, there are certain reserved words. Python is much more permissive than many. And actually, I should have paid attention to this because it even highlights it, that type is a reserved word. But I think that Python, it actually even works. So, which is surprising, actually. But it does work. Okay, so what I've done here is this. Again, we're in IPython Notebook. What I've done is I've just typed in the code that I showed you in the slide. That's already there. I'm going to run that cell. Okay, so now this class has been defined. And you can tell that I've run the cell because you'll see a number over here. Okay, now I'm going to do the same thing over here. I'm going to create this car, Joe car, and it has the values. Blue is assigned to color, type receives sedan, and speed is 100. All right, so I'm going to run this cell now, pressing that there. Okay, this is my bug. Okay, I changed this. I try to keep class names. I start with an uppercase. Does everybody see what the problem was? This is a case problem. I defined the class initially as car with a lowercase, and then I tried to instantiate an instance with car as an uppercase. And so that was my error, and that's why it didn't recognize it. So I could either change the other one to lowercase. I prefer to change this to uppercase. Okay. I went back and forth on this and did not rerun everything. Okay, so then let me run this cell again. Okay, so I just did that. Let me add another, go up one. That's not where I wanted it. Okay, so now let's take a look at, well, actually, you know what? Let's look at type, joecar.type. And let me show you that. Okay, so it gives me the right answer, right? It does what you expect. I don't know, I may have inadvertently redefined type, though, which is a bad thing. Okay, so I'm actually going to put a note in here. I can add some text, and that is my oversight, definitely. And so don't use reserved words for variables, like I did with type. Okay? All right, so that's generally a bad idea. All right, so, okay, hopefully this begins to make a little more sense now. So joecar.color, what will be the result of that? When I say, I'm going to do here is, yeah, it's going to just print it out. What will I see when we run this cell? Blue, right, and I'll see blue because, why will I see blue? So what I'm asking for, the way of the answer, is for you to follow the logic of what happened when we defined this class and then we created this instance or object, Joe_car. So when we define this class, we have this set of arguments over here where we have color as one of the arguments, and we assign color to self.color, and then down here I say joecar.color. That's the relationship that's going on here. Because this color here that gets passed as an argument in this constructor gets assigned to the value of color for this class, self.color, and I reference that by saying joecar.color. That makes sense in terms of how things relate? Yes?
So what is self doing in that? Because it's a list of 4 things, right?
Okay, so what self is over here, this is the Python syntax. It's actually, I'm not happy with the way they do this. What they're doing is, by having self as being one of the arguments, it defines it as what's called an instance method. A method that is present for every object. There are also something which I'm not going to go into, but you may run into this, something called class methods. And class methods are done in a way that they are used with the same values and data across all members of the class. And they're also class variables. So if you had essentially something that's globally shared within a class, that's what you would do it with a class variable. But that's what this is doing here, is it's indicating that it's an instance method. Other questions? Okay. All right, let's play with this a little bit. Suppose that I want to add an attribute to my class. I want to change my class. I say, gee, you know what? My class, this car, if I want to talk about a car, I really need to know about its length. Okay? All right, so what are the other changes I need to make to now define this class? To include that attribute of length in the class. What do I need to do? Add it to my def. So what do I need to do? And where's the, okay, so the def line over here, right? So this is a function, we're defining it. Where should I put it? Is it after speed? Okay. All right. And what else do I need to do?
You have to define on the tab section, it says length,
Okay, sounds like a good idea. By the way, you don't have to use this. As a convention, I generally use the same variable name in the argument as I do within the instance variables. That's not required. I mean, I could call this length-ish and then assign this length-ish. That also works. It's just a convention. It's a convenience for knowing what's going on. So both of those work. For right now, I'll just do this because I think it makes it more readable. You can make that association. All right? Okay, so let's declare this. We'll change that definition. We've changed it. I've just run it again. You see the number changed to 9. Okay, and so now we should have that, right? Now I should be able to run it in this cell right over here. Oops. What went wrong? Why when I tried to run this cell over here, didn't that work? And we just, I have to what? I have to assign a value to length. Right. So let's say length is 23. Right. I didn't put the close paren. Okay. All right. Okay, and now, so now I want to reference length. I've just created this object. I want to reference length. How do I print that out? It's going to be Joe Carr, and then what do I do? Can I hear someone else in the back? What do I do now? Joe Carr, and then what? Okay, I'll give you a hint. There's a dot. What are we after? We want the length, right? What is the name of the variable length in this car class? What is the name of it? I'll give you a hint. It's right here. What did I hear? Length. All right, let's run that cell, see if we get it. Yes, we do. Okay? That's really about all there is to it. I mean, there are a lot of sort of pieces here that you have to fit together. You've got to do this. You're defining this function, you're passing some values to it, you've got to assign them over here, and you've got to reference them. Now, suppose we can create variables that are not passed to us. So we could say self.quality, and we could just compute that in some weird way. Maybe that's this has no meaning whatsoever, but speed divided by length, times 1.0. Right, and I can define that class, and then I can down here. Actually, you know what? Let's. I'm just going to move that up. So it's okay. Now that I've defined that, let me add another cell, and I can say, okay, somebody else now. I'm going to put in Joe Carr dot quality. Okay, and I'm going to try this, and what's going to happen? What's going to happen when I run this? I'll give you a hint. It's this. Why did I get an error? Well, I ran this. I'll even run it again. I ran the declaration. I ran that definition, and I'll run this again, and I'll still get an error. Why did I get an error? Well, what happened? No, the quality was in the definition right over here. It's not passed as an argument. I compute it. That's okay. But the reason why is because the object that I'm referencing, I did it right here. The object that I'm referencing is the object that was created down here. This was created before I changed the definition of the class. So even though I don't see it as an argument here, this object right here doesn't have quality in it because I didn't create it then. And so I have to run that again. And then if I run this, so now it's created with this new definition. Now when I run it, it will work. Does that make sense, what happened there, the sequence? Very common problem because especially if you're working in this kind of environment where you're doing this sort of interactively. Okay? All right. Yes, question? Yes, you can. It's a little more sophisticated. Python is what's called a dynamic language where you can what's called reflect on what it is that you have in the class. And you can actually find all this with various Python methods and properties. But it's a non-trivial thing to describe how to do that. So, but you can do that. And that's a very useful thing to do. And people who develop sophisticated Python codes often do. Okay. All right. Other questions? Okay, all right, let me see if I had anything else down here. All right, so Let's go on to methods right now. And these are specifically what are called instance methods. I said there are also class methods. We're not going to talk about class methods. I'm just going to focus on instance methods. And I'm going to do this primarily in this with the IPython notebook. I think it'll just be easier. You get more of a feeling for it. So we've already seen one instance method. Remember, a method is something that allows you to do something, take an action. And that instance method was init. And init allowed us to describe, us basically pass values and set up values of attributes that are used within the object. So if we think about the things that a car does, well, a car can start, a car can stop, and a car can turn. I mean, let's just start there. Now, I'm not going to do anything more sophisticated than just print out the information that I've started the car, I stopped the car, and I've turned the car. I'm not going to worry about more detailed actions, because right now this is really all about you just understanding how methods get invoked. So the way you define a method is the same way that this init method was defined as it's used as a constructor. So I say define as a function, start, and then I put self here because it's an instance method. You always include self. Actually, Python will complain if you don't include self. Let's do that as an example. We can see that with the init over here. What happens if I don't? Okay, so suppose I delete the self and then I run this definition. It does not. It'll allow you to define it. The problem is then when you do a constructor. So if I then, I'll just copy this up here. If I then try to create an object, it won't find an init method for creating objects because it's looking for a class, it's looking for an instance object. So I run this cell and it gives an error. It says it takes 4 arguments and we gave 5. Well, what's going on here is the way it's counting is that this includes self as an implied argument. So there are actually 4 arguments that you gave. But when you create, and when you're using an instance method, which init is, it actually has an implied self in there. So it's when you see an error message like this, what it's telling you is that there's a mismatch here. And very often, I'll tell you one of the most common things is you forgot to put in self, because that's the 5th argument that is implied. So, okay? So that's the way you define these things, and then once you put it in there, it will work. All right, so let's go down here. So all of your methods should have an argument of self. They may have other arguments as well. So the way I've defined it is that start just prints out, I started the car. And remember, with Python, the way printing works is you give an argument a format string, and then %, and then 1 or more arguments that are a match with anything that's a % value thing over here. So, for example, print started %s car means %s means match that as a string with the argument. So that's the interpretation there. I see some puzzled looks. Let me do a little bit on strings, because I didn't go through, I'm creating strings. So let's see here. Let's do a little bit on strings. Strings. All right. Okay. All right, so let's see. Let's say, I'll call this creating strings. All right, that's better. Okay. All right, so you can create a string with a combination of a format statement, which has any text, this is text, then with some sort of % format descriptor. So let's start out with just s's. So %s as a string, and then that will match up with something that's a variable. It could be, or something that's a value. It could be any sort of a value. It could be like 33. Okay, and what this does is it interprets the first part here as a format, that if you've ever done formatting like in Fortran or other language, the same idea. And then the %, anything that's a % letter over here, one of the value formatters, will then match up with the successive values that are listed over here past the %. So then if I run this, what we see is that text substituted in that way. I think many of you have many of you done this kind of thing in other languages or seen that before? Okay, let me give you another example. There's not a lot of variations on this. I mean, the variations that come about is what is the type of the argument that you're formatting. So for example, I did this as a string. If this is instead a number, I would use %d. Actually, you know what? Let me not do this because I would rather have you be able to see this different examples. So if I said this is a number, I would say %d because that's the format type for number, and I'd put 33, and then I would run this cell. Okay, but if I did this instead with, let's do it like this. I don't think this next one works. If I say this is a number, and I don't think it does conversion. Let's see what happens here. And I put a string as argument, it gives me an error. I have to have the type consistent. Okay? And this kind of thing is very common. The only other thing you need to know about this kind of construction, this kind of description here, because obviously being able to construct strings is a really useful thing, is that you may have multiple strings. So let's say x, value 1 is %d, and value 2 is %s. So I'm going to have my arguments here in parentheses. And the first value is, let's say it's going to be 33, and the second value is 55. And what's wrong with this? What's wrong with this format statement? I'll run it, and we'll see that there's something wrong. Okay, remember we've got to match the types. We've got a %d here with a string. Okay, the d works with an integer, so I've got to take the quotes off. That makes sense? Okay, I'll run it again, and now it works. Okay. Well, it does it in the order that you've got it there. No, and if I switch these, actually, let's even do that. If I understand the question correctly. Okay, so the question was, let's try and repeat that. And so if I then just put, okay, so if I did this and this, is that what you're saying? That's not going to work. The reason why, and we'll run it and I'll show you. But the reason why it doesn't work is that %d, the first occurrence of the formatting statement, is paired with the first list of the value over here. I mean, these could be, clearly, just so that it's clear here and make sure there's no problem. If x is 33, so now x is going to be, and I can replace this with x. Okay, so I mean, it's that also will happen. But then if I wanted to do it like this, I would have to do it like this, right? And then that will, then work. Okay, all right. So knowing how to manipulate strings like this is very useful. Yeah.
So wait, why couldn't you put %s for both?
Okay, well let's try it. So if I did %s for both of them, then actually that possibly might work because there is some type coercion that occurs. What doesn't work is saying something's an integer. Let's see if that works. And a lot of these things, the rules can vary a little bit with the implementation. So let's see if we did this as a %s over here. Let's see if that's going to work. I mean, that actually works because it does the type coercion. But what you have to do, you have to try these things. And sometimes the type coercion works and sometimes it doesn't. The main thing is just this notion of the format statement and then matching up with the arguments. That is invariant. All right. Okay, so back to our instance method over here. We've got the start method. We're going to start a car. And so when so we've got a constructor here with the init. All start does is it says that we've started a car, and it tells us it's going to print out the color of the car. And then stopped, it tells us that we stopped, basically ran that method, and we're printing out the color of the car. And then turn actually takes an argument because we've got to say what direction we're turning. Okay, does this make sense? Because the methods are just functions that are within the class. Now, like all functions, you have to have the same kind of format here, that it's a def, it's a function name, it has arguments. Arguments in this case have to include self because these are instance methods. And it's got to have the colon. And then you indent at the same level of indentation for all statements in the block within that function. The other part, which hopefully is apparent, is that there's another level of indentation that all of these methods have because they're within the class. Because that's the way I describe something as being within the class. I give class, I give name, I give the colon, and then everything is indented at the top level at the same level of indentation within that class. That makes sense? So for example, if I did this and I said, okay, I'm indented, but it's not the same level of indentation as the other members of the class, and I tried to then define it, I run this, it's going to complain. Says doesn't match outer level indentation. It's got to be the same level of indentation. Okay? That makes sense? Okay? So just think of it as that in Python, the indentation level is equivalent to like begin end. Right? Because if I were to instead say begin, and then end the function, that's the same thing as knowing I'm at the same level of indentation. So everything that's indented the same belongs to the same function. Okay. All right, so when I'm defining an instance method, all that I'm doing is I'm defining a method which abides by these formatting rules and has an argument of self, possibly other arguments as well. All right, so let's go down here and do this. I'm going to take this apart maybe and make sure I think I have run this. Okay, I'm going to do this a little bit in pieces. All right, so let's see here. All right. Okay, so I'm going to create this. I'm going to run this cell. Okay, so what's going to happen when I run this cell? Okay, so the first statement here is going to create an object. And that object is going to have what for its color attribute? Okay, remember how that look. Let's look up here at the class. Color is this argument over here. I'm sorry, color is right here. Okay, so that's the first argument that you enter. The self is, just tells it it's an instance method. So color here corresponds to color here. Right? So if I were to do this differently, let's see, let's do another one too. Do this piece at a time. All right, so I'm going to run this method. I'm going to do joecar.color. What am I going to see? Here, run that. Blue. Okay, and I'm going to see blue because I assign, this is the value of color, this variable color, and color gets assigned to the value self.color, and self.color is what I'm printing out here. All right, so now I'm going to run this method, this line over here, so joecar.start. And since it's a method, it has to have parens over here. I don't put in the self. That's an argument that's just used within the class definition. And so it should run this method. And what should I see as output? Started blue car, exactly. That's what I should see as output. All right? And how about down here? What's going to happen here? So joecar.turn. Right, turned, right. So turned left in blue car, turned right in blue car, and then stop. Okay? Okay, so let's do one other variation on things. Let's create a new method. So this method is going to be accelerate. We want to be able to accelerate at a certain speed. All right. So, okay, actually, we're going to do two things. We're going to have a method called newSpeed, not accelerate. It's going to be called newSpeed. All right, I'll even get you started out here. Def new, we'll call it new speed. This could be a method, and new speed is going to have a value that gets assigned to a new instance variable called current speed. Okay, and I want to be able to change new speed. I want to be able to print out, you know, this is the current speed of my car. That's all I want to do. That's a feature I'm adding. Okay, so let's start out by thinking about this. Okay, so we've got two things we have to do here. Okay, so let's see here. I'm going to write down just a couple of things here. Just do this in Markdown. So here's the features we want. Okay, so we want to have method current or new speed sets value of instance attribute current speed, and a method new speed prints new speed current speed. Okay, so those are the things we want to do. All right, so what do we need to do to modify this class to be able to do that? Okay, well, let's take it one at a time. What do we see here? We see this attribute current speed. All right, that's instance. Do we have an attribute right now, current speed, that's an instance attribute? You see it up there in this list here in the init section? It's not there. That's because we haven't done it yet. Okay, so we've got to have that. All right, so what should we do? Okay, that sounds like a great idea. Self.current speed. What should we set it to? I'm sorry? Current speed. Well, we could define, we could add another argument. That would be one possibility. We could have the constructor do it. I'm going to do a little simple way where I'm just going to assume that the current speed when you create the car is 0. But that's true. I mean, that would be another possibility you could set. Okay. So good news is we now have this attribute available to us, this instance attribute. Now we're going to define this thing called new speed. Okay? All right, so I've given you part of the definition for this method, def new speed. I'm even giving you the right indentation level. Okay, what are the arguments? What's the first argument? Self, exactly, because it's instance method. What else do I need? So remember what this thing is going to do. It's going to set a new value to current speed. Yeah, right. It's yeah, exactly. Let's say current speed. Yeah, sure. This is going to be our new current speed. Okay. Okay, then what? New speed? Well, okay. I mean, you actually have that as an instance variable over here. You have the current speed already. I mean, is current speed? I thought that current speed here was going to be your new current speed. All right. I think that just from the point, and this is actually in terms of documentation, it's a good idea. Just this is really going to be a new speed. It's not the current speed. So I probably want to do that. It gave us the closing paren. What else do I need on this definition line? A colon. Exactly. All right. All right. What am I going to do down here? Print? What am I going to print? Okay. Now going, let's say %s, okay, %d, and then let's see, what we're going to do is what we're going to print out. What's the variable here? New speed. Okay. Okay. What will the value of current speed be? Well, it's still 0 right now, but we probably, if this is our new speed, we probably would like to change that. Okay, so probably have another line over here that self.current speed equals new speed. Okay, something like that. Now, the only other thing I would change on this, just from the point of view, and this is fine for sort of brainstorming about just how to piece this together. The only thing I would change about this is I would suggest that the first thing you do is you assign the instance variable, because that's really the semantics of what you're trying to do. Instead of printing out the argument, I would actually print out the value of the instance variable, because what this should be doing is telling you what the car state is. It will produce the same result, as well, but I think just in terms of readability, it's better. Okay, let's run this definition. So you see we're at 34, and that's going to change to 38 because we just ran it. Okay, now we can create. Well, let's do this again. I'll just do this down here. Okay, so okay, I want to check this out. What do I need to do? So let's say we'll call this. Well, I'll keep on using Joe car as a variable. Equals car of, what are my arguments here? It actually tells us, right? So blue, comma, sedan. I'm just going to keep to what we had before. Nothing special about that. Okay, now I want to see what happens with, so I probably, okay, well let me run that. Okay, now probably the next thing I want to do is I'd like to check out what the current speed is. How do I know the current speed of this car that I've just created? Dot current speed, exactly. Okay, let's run that. All right, that's great. Okay, awesome. Okay, now I want to change the speed. What do I need to do? New speed, everybody see that? Okay, and then what do I enter in as the arguments? Well, let's take a look at the method. The method has two arguments. We know self we don't include. So we just have to put one argument over here. That's going to be the new speed, let's say 55. All right? Now going 55. Okay? All right, so those are all the pieces of creating a class, adding a method. Many times when you add a method, you're also going to have to create another instance variable. All right, so I think we've done a lot of this. All right, so classes in Python, and then using classes. Yes, we've done the constructor here. That's the constructor. This is this notion again of showing that the class, when you're defining it, does not assign the values, but when you instantiate the class through the constructor, you're assigning the values to those attributes. All right, then we've got these methods. We've already seen one, underscore init, and then here are the methods that for each one of these classes. We see that every object in class car has the same set of methods. They all have the same methods. Okay. And we've also created a new instance method. So we've looked at these various instance methods, and we created this new instance method called new speed. All right. So it's very common. One of the powers of object-oriented programming is the way you get reuse of code is you have something that's a common abstraction. And that's where this notion of level of abstraction comes in, like car. Car is an abstract idea. But there'd be different kinds of cars with different accessories. So, again, sadly Dave isn't here, so I can't rib him about this. But let's say, my car is actually going to be different from his. So Dave has a fancy car. He has, new stuff in it. He has a Bluetooth player, and I only have a CD player. Okay, so I'm going to do play CD in my car, and he wants to do play Bluetooth in his. Well, since these cars now have different methods, they can't be in the same class. They have different methods. All objects in the same class have the same method. So they have to be different classes. But what we can do is isolate out those parts that are common to both of us and do what's called inherit. In other words, everything that's common we'll use for us, for our car, and then we'll extend from there. And you can see what that is. We have the same attributes. That's common. We have the first three methods that are all common. The only difference is I have a CD player and he has a Bluetooth. All right? So how do we do that? How do we make that extension? Because this is a very powerful way to create reusable software systems where a lot of code can be shared. It's a common way of doing it. And that's sort of this notion of abstraction. And this notion of inheritance is that you specify in the class definition what you're inheriting from. And you create essentially a tree is what happens. The root of the tree is something called object. So your root, your parent, in this case car, inherits from object. That just says it's the root. And then the class Joe car will inherit from car. So everything that was in car over here, all these attributes, all these methods that are common, will then be part of Joe car. The only other thing that's a little bit of a trick on this is that when I create a subclass, a lot of times I'll want to call the constructor, set the instance variables for the parent class. So for example, Joe car always has the attribute blue for color. That always has the value of blue for color. I want to do that. Now there's no reason for me to have a constructor in Joe car that says assign me the value of color because I know what the color is. So what I would want to do is instead call the parent class and assign the constructor. All right. So this is an example that where here it's not the complete class definition. It just shows you for the constructors. So here's the class car, and here are the instance of the variables that are passed in the constructor. And here's the assignment of those values to the instance variables. Joe car, what are the variables that will be passed when I construct a Joe car? Yeah, actually, if you look at the init method for Joe car, there's only self. Self is implied, so it actually will not have anything in there, any values that are passed. Instead, what happens is Joe car already knows that the value of color is going to be blue, that the type is sedan, that the speed is 100. And so what it does is if you see the code sequence here, when you do a constructor for Joe car, it has no arguments. And that's because Joe car is essentially calling the constructor for car and specifying use blue, use sedan, use 100. Okay, let's do this for a second too in Python notebook. All right. All right, so now we're going to do this inheritance stuff. Okay, so here we've got the class car, and we see it inherits from object. All right, and so this is basically the same code we had before. The only difference is we were explicit about the inheritance there from object, which not so significant. Okay, if I want to get all of what I've got here in Joe car, plus I want to do the play CD, I say that Joe car inherits from car, and essentially what that does is it essentially copies all these methods into Joe car. But I don't have to write it down because the inheritance tells me that. The only other thing that I have to do is I have to deal with the fact that since I already know that it's a blue car, a blue sedan that can only go 100 miles an hour, I have to somehow assign the instance variables over here. And the way you do that is you call the constructor for Joe car, for its parent. So the syntax is a little tortured here. What this says is super is the parent class. So the parent class, and you enter in the name of the current class, which is Joe car. And you got the self over here to indicate the instance. And then says run for that parent class its init method. So now we're up over here and pass the right values. So the syntax is a little tortured, but conceptually all it's doing is it's assigning the values of these instance variables. The other thing that could probably be, right. I mean, there are other ways to do this, but this is the most common way to do it. And unfortunately, the syntax is a little bit tortured. Okay, so if we run these, and we run this here, and we run this here, and then, okay, so now we're going to create a Joe car. Now this Joe car is an instance of the class capital J, capital C car, Joe car. So it's a different class than before. It's a class, instead of before it was just class car. And one of the consequences of that is I do not provide values here in the constructor. I don't pass any arguments because joeCar in its init does not require that. It instead, under the covers, calls car. So let's see, if I run this, that will just simply create the object. And what I can do is I can say, okay, so this joeCar, what is the type of this joeCar? Okay, and that type is joeCar, right? As opposed to just car. So if I ran back here, let's do this. Do this again. Let's see. Do this, and then I created a joeCar here. So this is a joeCar. This variable joeCar is a instance of class car. And so if I say then type of this joeCar, which is an instance of class car, I get something different. I get that this, oh, that's interesting. Oh, you know what? I redefined type. That's my problem. Okay, I can't do that there. Now that's the bug because I used type when I shouldn't have used it. So I apologize for that. All right. Anyway, so if I'd done this right, and you know what? Let's see if I call this. It doesn't matter what I call this here. Car type, and then I call this car type. This is going to be a problem over here. I think that'll still work though. Let me see if I can do it like this. And then I say class joeCar. It may still have a problem with me. Let's see if that works. What does it complain about? Invalid syntax? Oh, it's type, not class. Yeah, no, I screwed it up, so that's my problem. Anyway, it should show joeCar there. It should show car, rather. All right, so let's go down here for inheritance. Okay, so we see how this worked, is that I just referenced the car over here, and now what's happening is when I created it, it's a joeCar, and then joeCar.color, even though I did not specify anything in the way of color when I created it, when I run this cell over here, it knows it's blue, and that's because I ran in the constructor for joeCar, I ran the constructor for car and passed blue. Okay? This is the basics of what you need to know about the mechanics of object-oriented programming. Okay. In Python. And actually, any object-oriented language, you'll see similar types of things. All right. Okay. We got that with the inheritance example, and this is the specializing. Okay. All right. So you've seen some stuff on documentation, reading CSV files. I'm sorry. I'm getting ahead of myself. You've seen some documentation in the lecture that Dave gave, and sort of what the expectations are for good coding practices. I would recommend that typically what you'll want to do is you'll want to have documentation for the class, what that class does, and you want to have something for each method, like the inputs and outputs. And then it's, typically methods are fairly short, so there's usually not a need for a lot of detail about per line. But that would be the two things that you really need, are that for the class and then for the individual methods. All right. So I want to take a few minutes to talk about file I/O, in particular reading CSV files. This is probably the most common format that you'll encounter for the work that you do. And there's code in many languages, and even in Python. There are things that you can do to just sort of stock codes that you can pick up. But understanding how to do this is illustrative as well in terms of dealing with file I/O and the variations on this. So how many people here have done some work with CSV files in a language, either Python or MATLAB or anything? Okay, a little bit. So, I mean, basically what's going on here is, obviously a file, it's, data on disk, and, you write something, you output it to the device, or you read it and input it. I'm not going to talk so much about the writing part. It has its analog here. Let's talk about the reading part. So if you're going to read a file, and there are various different ways you can read files, but let's just assume you're going to read it sequentially from start to finish. and you're going to just read every line and store it internally as variables in the code that you're producing. So the first thing you're going to do is what's called open the file. How many people have encountered that phrase, opening a file? What that means is it's typically you're communicating from your program to the operating system that you want to have access to that file. And there's a lot of stuff that goes on under the covers so that the operating system can make an association between what's going on in your program and that data on disk. So that's what opening a file means. And in Python, the way this works is you're making an association with a Python object. And then you're going to repeatedly read parts of the file. Typically, we're just going to be reading a line at a time. That's the way it works, but there are variations. You're going to stop when there's no more lines left or chunks, and you close the file. Everybody know why it's important to close the file? You close the file because that says you're done with it. If you don't close the file, then the operating system thinks you still want it, and it may be that it will prevent others from using that file or you from using the file again if you try and open it again. So that's why closing it's important. And a common error in programs, and actually can be a sort of a nasty thing to deal with, is you forget to close a file, or you have an error that causes you to fail to close a file. So you need to go through all 4 of those chunks, those steps. Okay, so you allow others to access. So here's a common sort of code fragment for doing the sequence over here. There's a method in Python called open. It looks more, it's a function really, and this is sort of like a non-object oriented thing, but it's a common way to do this. So you'd say open, you give the file name. So it's a string. But I'm saying that this file exists in my current path. This is actually the data that we used in the Michaelis-Menten analysis. The R over here means read. So open the file for read. And what you're saying is then for all, so range here, remember this is going to generate a sequence of integers. I'm going to do is read each line in the file, read 6 lines in the file, and then print them. And I'm reading 6 lines because, everybody know why? Because the way, when you say range, it goes 1 through increments by 1 and then stops, doesn't do any more incrementing once it gets to 7. So this will actually generate a list 1 through 6, just the way the syntax works. And then FD, which got associated with the file, FD is an object just like a list is an object. And it has certain methods associated with it. And there's a method called readLine, which will read the line, and I can print the line, I can close the file. Okay, so let's take a look at that, and we'll sort of go from there, because that's sort of a starting point for looking at these CSV files. Yeah.
You don't have to specify like the file path or anything. You can just
the file.
You don't have to specify like the file path, like it's in this folder.
Well, if it's in your current directory. If it's not in your current directory, then absolutely you have to specify a file path. But if it's in your current directory, then that's implicit. All right, reading files. Okay, so that's what I've got right now. The directory that I'm in right now has this file. So I'm in good shape there. I'm going to execute this statement. And then what I'm going to do is, rather than worry about the loop for right now, I can just repeatedly run this cell. So I can print the first line. So the first line of the file is the header, the substrate, and the reaction rate. The second line, oh, I didn't mean to do that. Let me just run this again. I think I actually, yeah. Then what it's doing is it's going through the file step by step and reading it. So what happened here, let's see, I'm going to have to actually close the file. This is a great example. What happened is this is a stateful operation. When I read the file here, it then advances a pointer in the file. And now I'm actually at the end of the file because I inadvertently ran this loop. And I've run through all the values in the file. Let me go back here and close the file. So fd.close should do it. Okay, so now I'm back to my starting point again. Let's open it again. Okay, and now I'm going to read it. Okay, that gets the first one. I'm going to do the same thing again. And that's going to get me the next line. Okay, and so on. I can keep on doing this, get line after line. When I close the file, that causes me to start all over. And now I can't read it. Now it's going to complain because I've closed it. But I have to go back here and open it. And then once I've opened it, now I can read it. but then I have to close it. So does that make sense in terms of what's going on there? Good. Okay. Now, what we had before was a loop. And what the loop did is it looked at all the values in this range. And so actually, it's going to go well, let's see here. So this, if I say here 1 through 7, it'll give me 6 lines. So if I run this, I've just closed the file. Okay, so actually, I guess I have to go back here and open it again because it didn't open it yet. Okay, so now I'm going to run this. All right, so it gives me 6 lines. It gives me 6 lines because there's 6 elements in that list, 1 through 7. So it says stop at 7. Okay, there are actually 7 lines in the file, so I actually have to do this. Obviously have to go back and close it. Okay, I have to open it. This gets very boring, and then now I can print, and it'll actually give me all the lines in the file. But I better close it. Okay. All right. Yes.
Is there a way to just indicate read all?
Yeah, I'm getting to that. I'm building up to that. Okay. So needless to say, this is cumbersome, and the other problem with this is I don't know how many lines are in the file. So I mean, why am I doing it this way? So there's another construct in Python that allows you to do this, and it's a variation on a for. I mean, it actually is a for. So it's like a for loop, only what we're doing is we're looping over all lines in the file. So this right here says for all lines in this file. So that's what the interpretation of this. So just basically, it's generating a list just like you would think of otherwise. This is, and it's going to then execute this loop for every line in the file. So now I don't have to worry about how many lines. And the other part that's really nice is when it's done, it closes the file. So I can do this. I can then, okay, remember before I had to go back and close the file if I want to do this again. So suppose I said, well, wait, I want to run that same thing again. Okay, without doing close, I can simply just run it again because it implicitly closes the file at the end of the loop. So far, so good? Okay. All right, so suppose I wanted to then construct read a CSV file. Okay, so now I know how to now I see what the file looks like, right? I just printed it out. Right? And the way the file looks is I've got these headers here, which are the names of variables. These are strings, and they're separated by a comma. And then each value in each line is also separated by a comma. So the first value of S is 0.1, then 0.5, then 0.12. And for R, it's 0.11, and so on. Okay. So this is a comma-separated value file. What I want to do is I want to read all of the lines in the file and accumulate the data and also remember what the column header is. Those are the things that I want to do. So one way of going about this is, well, I can create a matrix, essentially. So I could have something, this is the data for the file, and so my matrix, one column, I'm just going to do it, the matrix is going to look like this. So the first, it's going to be 2 columns, and I've got 6 data values, so 6 rows, so 2 by 6 conceptually, and I'm just going to read each value and then populate this matrix accordingly. So I could do that, and here's the structure. Here's sort of the empty structure for it. So the data is this 2-level matrix, and then what's going on here is we've got this same loop where we're reading all lines in the file. This line here, what it does is it strips out the comma. It basically goes through this strip thing over here, and it says, okay, I've got this data over here. Find the comma, then isolate anything that's separated by the comma, and those are separate values that I want to know about. And those values become a list. And so that's what fields is over here. And then data 0 is this list over here, because this is a list of lists, essentially that first column. And data 1 is the second one. Okay, so let's run this and see if all that magic actually works. And then if I look at data over here, what happened? Okay, well, I do have this list of lists, right? I have two lists. So this is the first list, and this is the second list. I have 2 problems, though. Do you see the problems? Okay, so this is my first column, and this is my second column. One problem is that these numbers here are actually strings. I really want them as numbers. Okay. A second problem is that I've combined together the data with the headers. That's probably not what I want. I probably want the data separated from the headers. Okay. So here's something a little bit more involved to do that. It specifically says, okay, I want to get the list of the headers. I want to separate out the list of the data. And how do I go about this? Well, you know, I've got to remember that I read the first line. And once I've read the first line, and when I'm reading the first line, I'm going to pick up whatever on that first line. There are all those fields. Those are going to be my headers. And then if I've read the first line, then what I'm going to do is just pick things up, and I'm going to treat those as data. And that's what this stuff over here does. So if I do that and run it, and then we take a look at what the result is. Let's see here. Let's just look at, oops, let's see here. Let's see, I'm just going to print headers. Okay, and run that. Okay, that's what I would have expected. And then if I want to look at, and let me do it like this. Yeah. Okay, and then print data. Okay, and now I'm getting what I want. This is the first, these are all numbers, and this is the first column, and that's the second column. Okay? Okay, back to the slides. We're almost there. All right, so reading a CSV file is where we were. Okay, so we read the CSV file, we saw the open, that's good. We saw we could do this much better. We can use that for loop. Here's the CSV file. We have our for loop. We get to strip off the commas, find the fields, and we've got the output over there. Okay, and then we got converted the headers right, got them right. Okay, so what we're interested in, I mean, this is, you know, an application of this kind of concept, going back to the Michaelis-Menten analysis and then this notion of classes, is that for Michaelis-Menten, we'd have a set of data. It's a CSV file, just like we saw with substrate and reaction rate. That notion of reading data from a CSV file, though, of course, is not just something that you want to do with the Michaelis-Menten enzyme analysis. And with the flux analysis that David talked about, it'd be really good to do that too. You have, you know, much wider columns, much wider rows, more variables, but still it's probably in a CSV format. So it's really nice to be able to isolate out this capability to read a CSV file, put that as a separate class. And then Michaelis-Menten would just have 2 columns, and, you know, flux analysis would have 20 or more. Okay, so we have 2 separate classes there. We've got this class data, which is going to just be you know, any data or value, and it's going to know about, if you look at its attributes, it's got a file name, it can read, it can get names, it can get data, and the enzyme data can do all that, and it also estimates the enzyme parameters. Okay? It makes sense in terms of a class structure? I'm sort of running up to the edge. Give me a minute more and I'll be done. All right. Okay, so this is what your homework is to implement the Michaelis-Menten analysis. So for the last homework, you're going to write that in Python. Right? So you just basically translate what you did in MATLAB into Python. And for this homework, you're going to make it object-oriented. But just a piece of it, just, you know, this notion of reading a CSV file. Okay? All right, great. Just a minute over. If there are any questions, I can answer them. You know, I have a minute or more, so more now. Okay.